Okay, so in this theorem what we have to prove is, alright, so E1 and E2 are subsets of Rn, right? And then we are considering the interior of E1 intersection interior of E2 will be equal to interior of E1 intersection E2. So these both are same. So for example, if I take this left hand side and I take an element x belongs to this interior of E1 intersection or interior of E2, that implies x belongs to this both. Alright, now if x belongs to this both, that means we might have the radius of these two will be like might be different in R1x and in R2x. These are subset of this and this is a subset of this. So with different radiuses we have x. Alright, now now we have this is after that we are considering another neighborhood that is with the minimum radius r, that is minimum, that is r will be equal to minimum of r1 and r2, considering this radius, and then, sorry for the focusing issue I'm having here, we are considering another neighborhood nrx which is having radius which is less than the radius of these two, and this nrx we know that it is a subset of n1x and r1x since it belongs to this, and also this radius nrx is a subset of nr2 of x. Alright, so that implies this nrx, the small neighborhood of x with the radius r, is a subset of E1 intersection E2. From that it implies that x is an interior point. Alright, so if you know the definition, how to prove definition of interior point and how to prove interior point, you can easily use that concept right over here. Alright, now considering another example, considering the x belongs to from that, sorry for that, x is an interior point of E1 intersection E2. From there it implies that x is an interior point of E1 intersection E2. Alright, from this we can write interior of E1 intersection of interior of E2 is a subset of this E1 intersection E2 whole interior. We get this. First we have taken this and then we prove this. For example, repeating again, some element x belongs to this E1 and some element x belongs to this interior of E1, and then another element which belongs to this E2 with different radius. Just we are changing the radius with nr1x and nr2x. These two belongs to the E1 intersection E2. Then these two are basically subset of nr1x is a subset of E1 and r2 is a subset of E2. Now we are considering another radius with the minimum of these two radiuses r1 and r2. Then this minimum radius and neighborhood nrx is a subset of this, and this will be the subset of this. Hence From that we can conclude that NRX is a subset of E1 intersection E2. From there we get that X is an interior point because we are considering this E1 intersection E2. Now conversely we are assuming that X is an interior point of E1 intersection E2. That means we are taking basically X, now we are taking that considering that X belongs to this interior of E1 intersection E2. So that implies that X belongs to E1 intersection E2. Alright, so there is a neighborhood of exists NRX which is a subset of E1 intersection E2. Alright, from there we can get this NRX neighborhood is a subset of E1 and also E2. From there it implies that X belongs to, from there it belongs to X belongs to interior of E1 and X belongs to interior of E2. From that we imply that interior of, because we have used this one, we have used this condition, that is this condition, and we got this. So that means we can write interior of E intersection E1 intersection E2 is a subset of, this is what we got, right? Interior of E1 intersection of interior of E2. So this is pretty much related to interior of E, and if you want I can explain the union also. That is instead of intersection we'll be having a union instead of U. That's it. So the theorem will be pretty much similar to that. So you can do it similarly. Now one more thing that is related to E, limit point of E, I will explain that in the next video. Okay, thank you for watching.